Okay, so today is the last day of the week, and we are going to be working on compound inequalities. So yesterday we worked on just linear inequalities, and today we're going to work on what are called compound linear inequalities. So this is Objective 2.3c. The topic is compound inequalities, and the major difference, or the major thing that you need to clue into today, is what is the difference between conjunctions and disjunctions? Because the way you solve inequalities is always the same. It's how do you interpret their answers. So a conjunction is a different kind of answer than a disjunction, because conjunctions are intersections, whereas disjunctions are unions. So let's take some notes to just define that and look at what it looks like. And then we'll do some compound inequalities. So what is a compound inequality? Compound inequalities are two inequalities joined by and, or. And those are little tiny words, but they have a lot of meaning. Okay? And is an intersection. It has to be true for the first inequality and the second inequality. So when we graph their solutions, we're going to pick the solutions where the two solution sets overlap, where they're intersecting only, versus it has the answers can be true, the solution sets can be true for the first inequality or the second inequality. And so that's what we call a union. Now unions is all the solutions that are graphed, all of them. So that could be their unique solutions that are different from each other, and it includes also the solutions that they share. Okay? There's a big difference between and or. Like your mom says, you can leave after you do the dishes and you clean your room, versus you can leave after you clean your room or do the dishes. I mean, there's a big difference in those two little tiny words in their meaning. Okay? So what is a conjunction? You may not have heard that term before. A conjunction is also known as an intersection. Okay? So in a conjunction, you will see the two inequalities either written and separated by the word and. For example, x is greater than a and x is less than b. You can also see it as a single statement that has both inequalities in one statement, and the x will be in the middle, and then it'll have the two boundary numbers on the end. Okay, so you'll have one bound on the left, less than x, less than the other boundary number on the right. And so if you get an inequality written in either form, that's a conjunction. So basically what this means, because you see the word and, is that the solutions must be true for both inequalities. Both inequalities. Okay? So if I were to say, for example, that here's the set, I'm going to use a Venn diagram to illustrate. Okay? So this is x is greater than a, and this is x is less than b. And what I'm looking for is that solution. Where do they intersect? That's all I want to know. If we get answers when we're doing a compound, a conjunction, and our answers do not overlap at all, and there's the answer for this inequality doesn't have anything in common with the answer for that inequality, then there is no solution. So that's an option when you're solving a conjunction, where you might have some answers that overlap, and then something else that it could be is you could have one set of solutions here, and then inside that set of solutions you could have another set of solutions, and so their overlap would be the only part that's true for both inequalities. So that's what we're looking for. With a conjunction, you want overlap only. We'll do some examples here and put it to math practice in a second. So there's a conjunction. A disjunction, combined by the word or, is also known as a union. Okay? So disjunctions are always separated by the word or. You will never see a disjunction written as one statement that it has two inequalities embedded in it with boundaries on the outside. Disjunctions are always separated by the word or. So x is less than or greater than, that doesn't matter. Some boundary, or x is greater than or less than another boundary. Okay? So you'll see the word or. Solutions must be true for at least one inequality. It can be true for both, however, and that's what makes unions, excuse me, a little bit tricky. So when you are working with disjunctions, you're going to select the solutions. All the solutions, everything that you've found is the solution. So everything two inequalities have in common and everything they have that is unique, because it just has to be true for one or the other, but it still can be true for both. So basically unions are inclusive of everybody versus conjunctions are exclusive of anything they don't have in common. So only common, okay? So very disclusive. Here is very inclusive. Your answers will be all of the solutions that you have found. Okay, so if I were doing a disjunction in the form of a Venn diagram that had overlap, then my solution would be all of what they have that's unique and all that they have that is common. So it would be all of this. Okay, that would be a disjunction. Or if we had one that looked like this and then one that looked like this, our solution would be all of that and all of that. And when there's no intersection, you use a union to connect those. You could also have one that looks like this, where one set of solutions is inside the other. And so everything, what's unique and what isn't unique. That's a disjunction. Okay, remember, or is disjunction and is conjunction. But most conjunctions are not separated by the word and. They usually are written as just a compound statement. Okay, so let's take a look, excuse me, at this one. It says solve -3 is less than 2x plus 5 is less than or equal to 7. So because this is a single statement, one statement, this is a conjunction. So this means that you have two inequalities that are connected by the word and, theoretically. So our solution has to be what solution both inequalities share. So what I like to do when I'm first just going over this is I like to separate them and write them as actually I don't like to do that. I like to put the x in the front. So 2x plus 5 excuse me, is greater than -3. And I'm going to switch to blue. This is your other inequality. 2x plus 5 is less than or equal to 7. So we have these two inequalities combined by the word and. So our solutions have to overlap. Because the answer for the first one and the answer for the second one have to be true for each other. That didn't make sense. Let me explain it this way. So we'll subtract 5. 2x is greater than -8. Divide 2. X is greater than -4. So x is greater than -4. There are a lot of answers in that solution set. Goodness, I apologize. Oh my gosh. I feel so bad for you guys when I make videos. Oh my goodness. Okay, let's solve the other one. Subtract 5. 2x is less than 2. Divide by 2. So x is less than or equal to 1. So what we're looking for is those are two massive sets of answers, right? There's a lot of x's that are less than or equal to 1, like infinite negative answers, Versus over here, there's a lot of numbers that are greater than -4. But we're looking for the solution that's true for both of them. So sometimes it's useful to graph the solutions. So -4 is here, 1 is here, and just by the way, make sure you always write your numbers, your boundary numbers, on your number line from least to greatest. So I'm going to grab my red pen. Greater than 4, so I'm going to do open because there's no equal sign. Greater than 4 goes like that. Less than or equal to 1, so I'm going to close that, and I'm going to go like that. All right, so I have to choose the solution sets that are true for both. So that would be this section that would be true for both. And I know that because I could just do a quick check. Like if I pick 0, 0 is in both of those solutions. 0 is greater than -4. Check. 0 is less than or equal to -1. Check. So 0 is a solution for the first inequality and the second inequality. So 0 is part of our solution. If I were to pick over here 5, and I were to plug a 5 in, 5 is greater than -4, check, and 5 is less than -1, no check. So 5 is not true for both of them, and so that would not be in our solution. Okay, so if I'm now going to actually graph my solution set, this was just scratch graph to help me figure out my answer. What I would finally graph is this. Open from 4 all the way to closed at 1. And that would be my solution set. Okay, so all of the numbers that they have, all the solutions that they have in common are the solutions to my compound inequality. I also could have just solved it like this. -3 is less than 2x plus 5 is less than or equal to 7. In order to solve it in that original form, we would just isolate the x in the center of the any big statement. So we're going to have to subtract 5 to all three sections. So we get -8 is less than 2x is less than or equal to 2. And then continue to isolate x, so we'll divide every section by 2, and we get -4 is less than x, right? So that means x is greater than -4, is less than or equal to 1, and x is less than or equal to 1. So that would look like this. From -4, x is between them, and I know that this is a pretty good representation because -4 would be the least value and 1 would be the greatest value, and this is a less than statements. So -4 is less than x, and x is less than or equal to -1. So that would be my solution. So you can use that method there if you know how to interpret what that statement means. This would be different if it said -4 is greater than x is greater than or equal to -1. Now that's a problem. Let's put out a positive one, because this says x is less than -4, which would go like this. X is less than -4, and x is greater than 1, greater than or equal to 1. That's different. So that's not an intersection at all. So that would be a no solution if that were the case. So you just have to be careful if you're going to just leave the inequality in its compounded form here, that you can interpret what this final statement actually means. Okay, let's go to the next one. So again, we have -8 less than x minus 9 less than or equal to -16. This is another compound statement, and this is a conjunction. Okay, so these two statements are combined with the word and. It says this: -8 is less than x minus 9, and x minus 9 is less than or equal to -16. So we are looking for intersection. Intersection only. All right, so again, I'm going to separate so that I can illustrate. So again, I'm going to just flip the red statement. X minus 9 is greater than -8. I'm going to go ahead and solve that, and then I'll switch to blue. So add 9. X is greater than 1. and x minus 9 is less than or equal to negative 16, add 9, x is less than or equal to negative 7. Okay, so now I'm going to graph that. So negative 7 would be here, and 1 would be here. Greater than 1 looks like this. Less than or equal to negative 7 looks like this. Okay, so I see no intersection here. So if I pick a number that's in this section, like for example, I'm going to switch back to my black pen here, negative 10. If I plug that in here, negative 10 is greater than 1 that's false. And we have the word and here, which means negative 10 is not a solution, even though it's true for this side. That's true. It's not true for both. So that's not a solution. Nothing in the middle would be the solution because nothing in the middle of negative 7 and 1 is true. And anything over here is only true for this red function or this red inequality. And so when if I were to graph the solution on a number line, my number line would look like that with nothing graphed, just a blank number line. So this is a no solution. On your homework, you'll have to type in no solution. Spell it right. I don't care about capitalization, but spell it right. Okay, and that would be that. Now, if you were wanting to be a little more efficient in your solving process, the first thing I would do is I would flip this statement because this should be the smallest value and this should be the biggest. So I would rewrite it as negative 16 is greater than or equal to x minus 9 is greater than negative 8. Because I flipped the statement over, I also had to flip the inequality statements signs over. So we'd add 9, add 9, add 9, and here we have negative 7 is greater than or equal to x is greater than 1. Well, there's the problem here because this says x is less than or equal to negative 7 and x is greater than 1. And so if I were to graph that, that would be a problem because x has to be less than negative 7. And x also has to be greater than 1, and that doesn't work because x has to be between them, not on the outsides of them. So I think something here that you could just write down as a reminder is that if you're going to use this solving method, you want it to go least to greatest, and between them you need less than symbols. Okay, so that would be, and then that would be bound A and bound B. Whether you have greater than or equal to, that doesn't matter, but you want it to go least to greatest and using less than as you read it left to right. And that way you can graph the points that are in between them. If you can't do that, if you have this is least to greatest, but you have greater than, then that's no solution. Okay? All right, so those are your conjunctions. Now let's take a look at these. These are your disjunctions, and we know they're disjunctions because they're joined by the word or. Okay, so let's do this real quick. This is a disjunction. So I'm just going to write disj. Okay, so these are or. So true for one or the other. So common, that's the overlap, and unique. Remember, unions are inclusive of everything, every solution. So what is common and what is unique? So let's go ahead and solve. So we'll add 5. 2x is less than or equal to negative 2. Divide by 2. X is less than or equal to negative 1. Or, and remember, that's a big deal. It's just true for this one or that one. Add 5. 2x is greater than 6. Divide by 2. X is greater than 3. So let's graph that and see what it looks like. So left to right, negative 1 and 3. less than or equal to -1 looks like this. So all the solutions to the left of -1 are true for that one. And then greater than 3, that's this direction. So all the numbers to the right of 3 are true for that one. So if I were to pick -5, and I plugged it in here, -5 is less than or equal to -1, that's true. Or -5 is greater than 3. Well, that's false, but it doesn't matter because it says or. So check, that is part of the solution. So what would that look like on a graph? It would actually just look like that. So I don't have to regraph that to graph the solution. In interval notation, all of the solutions between -infinity and -1 closed. And because there's a gap between our solutions, we're going to have to use the union symbol and then open from 3 to infinity. And that would be your solution for example 5. Okay? And here we go, example 6. Okay, so again, we have a disjunction because of the word or. So we're looking for everything that they have in common and every solution that they have that is unique because unions are inclusive. So we'll subtract, let me get my red pen here, subtract 2, 2x is greater than or equal to -9. Divide by 2, x is greater than or equal to -9/2. Or add 2, 5x is less than 0. Divide by 5, x is less than 0. So let's take a look at those solutions. So we have -9/2, which is to the left of 0, and greater than or equal to -9/2 would be going this direction, and less than 0 would be going this direction. So remember that the solutions just have to be true for one of the two inequalities. So everything in blue is true for this. Everything in red is true for that. So my solution would be all that they overlap, all of their overlap. Remember, unions are inclusive. So basically, it's the whole graph. And it's even this whole right here at for the blue equation where x equals 0. Because watch, if 0 is the number I'm plugging in, 0 is greater than or equal to -9/2. This is true. Over here, 0 is less than 0. Well, that is false. But it only has to be true for 1. And so your solution would look like this. On a number line, it would just be the entire number line. If I had to graph my solution, it would look like that. In interval notation, like that. In Canvas, you may have to type in all reals, okay? And so there you go. The big thing here is that you figure out the difference between conjunctions and disjunctions. Remember, conjunctions, intersections only. Disjunctions, inclusive. Intersections and unique solutions. And that's the big deal. And versus or, they have different meanings. And have a great day. Your assignment is on Canvas. Bye, guys.